Welcome to the Future Living Lab podcast, your resource to find conversations about industry professionals, architecture professors, and instructors. We're your hosts, Kyla
and Matt. In today's episode, we discuss the next generation of computational designers. As emerging technology is becoming increasingly integrated in the architecture field, this begs the question, how can computation be an extension of our designs? To help us unpack this, we have Sadi Wali. Okay, Sadi Wali, thank you so much for coming onto the podcast today.
Happy to be here.
Awesome. So today we're talking about computational design. So this is something you specialized in, and now you're doing your master's in it, and you're also working in computational design. I feel like we could just start off with, why is computational design so important to you?
Well, to me, it's just like any other tool. I did go into computer science straight out of high school because I saw that as the biggest moneymaker career that I could go into at that point. And 2 years in, I just did not like it at all. I did 6 semesters of that and decided to switch to architecture, which was actually my second choice, straight from high school. And I guess I had a passion for computer science, and now that I'm in architecture, I just wanted to combine the two. And it worked out. So the computational design field is still growing, and I think this is the right time to be in that field. And it's something I like to do.
So you saw a niche for computation in the architecture field, and you thought you could take your comp sci skills over to that?
It was kind of like a happy situation. I wasn't planning to do computer science or any sort of computational design in architecture. It just happened that U of T has a good program for it, and the tech stream really helps excel you in that direction.
Cool.
Because of your background in comp sci, do you think having that background kind of helped you in the computational design field?
It definitely did. I want to say that I could pick up some of the software much easier. But part of it also was that the school had some really good teachers. One of my first classes was with Brady Peters, who's you all know Brady Peters, super smart guy. But also one of my TAs in that tutorial, John Nguyen, he was very passionate about his teaching, and he kind of set aside a lot of time for students, and that helped me understand the topics of computational design. And I forgot what the rest of the question was, but it definitely helped.
Yeah, I mean, following up on that, how much do you use computation in your designs, and is this computational, these software languages, really important for you to get your design voice across? Is this a design style that you're really interested in? How do you use this in your designing process?
For me, it's more about a workflow. It helps me get to the final design faster. I kind of consider myself to be a lazy person, and if I have to repeat something over and over again, especially with iteration, which is something you do a lot in architecture, as you know, with any opportunity I get to use Grasshopper to simplify or automate a task, I will do it. And that helps, I guess, save me time overall. And there's also some things you could do that you couldn't do by hand, LCAs as a popular thing right now, lifecycle analysis. It's really popular in the industry. So at work, we use that a lot for projects, as well as climate environmental simulations. That's very popular for at the start of the project, when you go to a client and you want to pitch an idea as an architecture firm. They want to see that you can look forward, and you have the technical aptitude as a firm that other firms may not yet have. So that's
interesting. That's a really good way to frame it, actually, to learn the process properly so that you can use the tools effectively and save time over the long run, which is something I feel like is missing, especially in the first few years of your undergraduate. People try to brute force so many of those repetitive tasks, like you said.
So your work sits in like a newer space between design and computation. So when you're starting a new project, what usually comes first to you? Do you start with the concept, the geometry, or the tools that you want to use, since your niche is computation?
That's an interesting question. I do start with a concept. I think for me, like hand sketching is a really good place to start. And the tools come into play, but more towards the end. If I have a good concept down on paper and in my head, then I'll like sort of ask myself what I need. Not to like design. We always use just Rhino usually to design. But when it comes to like selling your design and communicating it in a way, like with animations, I might decide to use like Blender or Cinema 4D for that. And if it's like more about the rendering, then it's like V-Ray, obviously. For like analysis, like environmental analysis or LCA, in some of our studios, we had to do that. And that's always good to include in your projects. And for that, you'd need like Grasshopper, Ladybug. So the tools come into play, but it's more the design. I think for me, it remains like it's conceptual first, hand sketches, and then moving on to like modeling and making like the modeling part easier with tech or with Grasshopper.
So basing off like your experience in the tech stream, since you did do an undergrad here, how has that informed maybe your work in the MArch program right now? Do you think you use more of what you've learned in the undergrad?
I'm actually struggling with that right now. In undergrad, I think the tech, especially in the tech stream, it's very well laid out. Like the program itself is geared towards tech because that's where we go into in second year. But in masters, it's sort of like very much, from my experience, the program is set out to be like for like a design oriented person. They do sprinkle in a little bit of like tech requirements, but it's always like towards the end. Like you have to include this LCA analysis or this climate analysis, but it's not really part of the design workflow. And the professors, not all of them are familiar with that workflow. So I wish there was a bit more like tech start from like a get-go. That would have been nice.
Good. That's very insightful. Thank you.
Do you feel like in your projects, your effort and design or software efficiency is recognized, especially in school projects?
Are you asking like personally or just in general?
It sounds like you use computation really to make the workflow more efficient to reach the design you want that maybe you start on paper, but it's not really as like this big flex that you can use these super software functions. So do you think that just with that profs recognize when you're presenting your work, or that it's noticed by firms that you're applying for?
I think like the firms sometimes they definitely do take notice, especially since the computation comes like, for me at least, towards the end where it comes like it's time to like present, show your work. So animations is something like I think I did a lot in undergrad, especially since we had when I was doing ARC 380, this was during COVID, so it was all online. So we had to really rely on like the screen and like how do you show like all of your projects like just through a screen without any paper, without any models. So at that time, like knowing a little bit of 3D modeling software, as well as like, I don't know what you would classify Cinema 4D. That's what I use, but like I just
also the 3D modeling.
Yeah, 3D modeling, and that was like so I knew that like I learned that software like way back before I ever got into architecture, just as like a fun thing. I used to like watch a lot of tutorials, and at a certain point, like I think I had a YouTube channel, and I made like an intro in Cinema 4D, and there were a lot of tutorials online. So that's like another good thing about the internet. I mean, there's so many good things about the internet, but learning in general, like you could do so much on YouTube. So I think I kind of diverted there for a second, but Clients do, like, architects typically don't. I mean, they have really nice drawings and they have really nice like visual language. But when you add in like some software, like with animations, also in modeling, you can use it's not computational design, but digital fabrication to really, like, if you're 3D printing, don't just 3D print the whole model in like one go. You have to design your model to be a model. And when you show up with a model that you can kind of take apart and like play around with, and that's enabled by like your pre-planning in software, and then eventually like fabricating it with 3D printing, which is like very precise. That kind of shows, I guess, a level of understanding of like not only just the tech, but also like your concept. And that's always like well received.
Yeah, that makes sense. And yeah, I agree. Designing your 3D model, for your physical model is something I'm doing right now as well in second year. So yeah, that's interesting. I want to ask you about your master's specifically. Can you explain your thesis and maybe how computation enters into that?
Sure. So right now, like, my thesis is about, it's actually just like building a robot. It's not really architectural at this stage, but I'm looking into creating a sort of like a motion system. So like a cable driven parallel robot, which is something that you could find in a, let me rewind for a little bit. The primary use of this like robot would be to like 3D print, but at a larger scale. Because right now our machines that 3D print are like small and you're limited by the footprint of the machine. But how a cable driven robot works is like, instead of using motors and like linear actuators, it uses cables. Like you can use 3 or 4 cables, like hook it onto corners of a ring. And just by like lengthening or like pulling on certain cables, it can like move through space. It's not as accurate as or precise as 3D printers these days, but it's like interesting to me because it enables you to bring in a sort of like a fabrication machine to your home. You can set it up inside any room and kind of like leave it there. And the idea is it allows you to like 3D print larger scale items, maybe like furniture, chairs, tables, etc., potentially, at a very accessible way. And you don't need to like dedicate an entire room to like have this large 3D printer. It's just like, it's sort of like a package that sits, it's like this big. That's the idea. That's the goal. Struggling with connecting it to an architectural, I guess, like angle. But I do see like value in bringing in like fabrication and digital fabrication into like the household. Just like we brought in like 3D printers from like the factory floor to industrial, to first of all institutions, and then to like the household. Like everybody like knows what a 3D printer is now. And a lot of us have it like at their home. So having like more digital fabrication and robotics in use inside the home is interesting to me. So I'm trying to see how far I can push that.
That's so cool. Yeah. Let me know when I can rent out that machine for next year so I can print out my furniture. Yeah, that's really interesting as well for your thesis, how flexible I guess you can be within the architecture master's, but I guess you still have to figure out a way to tie that into architecture too.
Yeah, I think I have like a really loose connection to architecture right now, but like it really depends on your advisor as well. There are some advisors that specialize in like more conceptual, more computational. So my advisor, thankfully, I was able to find someone who understands like computation in general and is flexible, and she's like willing to let me do this at least for this semester. And I'm learning a lot from this, but and I do have like some tie back to architecture right now, but I'm like going to leave that towards the end and have fun with it, like while I'm like building it.
Yeah.
Sick. That sounds so fun.
I was just going to build on like what you're talking about. I was just wondering how like because you're studying like architecture for probably 7 years by now. How have you amalgamated to making this a machine, or like what was the spark that gave you this idea, maybe instead of like, except for like bringing this thing into the household, or the initial spark?
So the reason I picked this like idea to build a robot is partially because I did something similar in my undergrad thesis. I used like a 3D printer controller to essentially create this like gantry system that like moves in three axis, and it just used to pick and place these MDF blocks. And there was an app that went along with it, so you could like place blocks inside of a digital space with other people, and this robot would like build something. But this all sort of started with kind of like me trying to really capitalize on like what I know best, which is like less about like the design sense or like, you know, like getting the capital A in architecture, but more about like using computational design, like a little bit of product design, a little bit of programming, and like whatever fits with that is what I sort of came up with, which was the robot. And I really like digital fabrication. I don't know if you could tell, but ever since third year, I think it was third year, or maybe it might have been second year, I forget. But I've been working with the digital fabrication lab at Daniels, and I've been very fortunate to not only just to work there and like support the staff and the students that like use the machines, but also like experiment in my own way, like on the machines. And it's been great to like have access to that. Yeah.
Awesome. We'll talk more about your work as well at WZMH and your work as a computational designer. But building off of this master's, do you know what direction you want your career to head into? Are you going to be an inventor, or are you going to be an architect, or continue in computational software?
I don't know where this is going.
Yeah.
I don't see myself as like an architect per se, like in the traditional sense. More into fabrication, I think. More into right now, like my computational design position is like something I enjoy doing, and I can go back to that, or I could like try to include some of my like more robotic interests and I guess like manufacturing or like making something. So there are companies that I'm like looking into that I'm interested in working with. But at this moment, I don't know.
Well, yeah, that just speaks to how many options you can get out of a design degree. And
yeah, and like architecture as a program is like so broad. Like you have people here working in like film industry, like Jay Pooley. You can work with like so many different materials like woodworking, and you could really take it anywhere, into research or into like architecture. So that's exciting.
Yeah, I feel like you're very interested in maybe how to make architecture more accessible through the manufacturing side. And also, aside from that, you're also like a great teaching assistant for all the tech courses in the undergraduate program, and also teaching me during the design build. Have you have any interest in pursuing teaching professionally in the future?
To be completely honest with you, like I'm really bad at reading, and I hate reading. And I know that you have to really like, teaching is more, it's not just being like able to explain a topic. You should also like know a lot about the industry. And for me, like I learn fast, but I have a hard time like retaining a lot of like information. So I feel like I won't be such a good teacher if I were to be, but it is something I was like interested in, especially because like some of my, like, I guess the most important people I that inspired me in the faculty, like are teachers, obviously. And it does, like having been a TA for like every semester I've been at Daniels, like I've had an opportunity, like tremendous opportunity to like teach and like see so many people. And there's always like it's an interesting, it's always like something new, every year. Like it's not like a boring day on the job. So teaching is very exciting to me. And I would consider it, but it would have to be something like I'm like passionate about.
Yeah, makes sense. It's good for you to have that avenue, but you get to decide what you want to do as well.
Yeah.
Okay, so I want to talk about WZMH. Obviously, you've been working there for almost 3 years.
On and off, yeah.
On and off, okay. So what is it like? Your title is computational designer there. So what does that mean to have that title, and what do you do? What does computational designer do at work?
Yeah, so typically like a designer, like an intern or someone who would go in would like work with Rhino, work with Illustrator, Adobe. I also do that, and I also like do a little bit of design. But mainly what I do in my day-to-day, at my firm, it's sort of a unique situation. I was hired more to work on like their R&D division. So at WZMH, they actually have a very small but like blooming like R&D division where they actually work with robots. They do like 3D printing. They do like material science. Like they work with other universities too. I think there was a project with TMU where they put it was called Carbon Lock. And the idea was to incorporate like 3D printed spheres filled with carbon in concrete as like kind of like fill. That was like an interesting project. And that was like the more recent one that I saw. I wasn't directly involved in that one, but so computational design specialist can mean a lot of things. In traditional firms, it might mean, again, like you working with environmental sims. So like daylight analysis, CFD, or maybe even a little bit of, there would be LCA as well. Some of the new firms are doing, they have a dedicated person for life cycle analysis because LEED is like carbon neutrality is a big deal right now, and it should be. Like also in RFPs or like when a firm goes out to a client and they want to do they want to pitch their design or like they want to get a job, they can show that they have like a computational designer or they have like ideas to incorporate technology, or even like AI these days is a big thing. So having someone who can like having someone who can do that and incorporate that into the workflow at a firm is a big deal. So yeah, my day-to-day is like basically when I was working there full time, it was basically a lot of environmental simulation, a lot of LCA, and a little bit of design. Also made some like apps for the office, like just some internal office apps. And more recently, I guess like the major thing I was also doing was sort of managing the development of an architectural software. So the firm wanted to create a standards app, which is like an application that helps them manage design standards for their like clients that have lots of branches. I'm like losing the word here, but anyways, one of their clients is RBC, and they have like lots of bank branches, and they have like the same design throughout, right? So you need something to like manage that standard. And if you have any changes, you don't want to be sending PDFs every single time over email saying like, hey, update this page. So the idea of the app is like to kind of do that all online. So that took a big part of, actually, it was like the main thing I did at the firm was to coordinate between the developers and the architects. So being like sort of the middle person who can understand what the architects are saying, but also what the programmers are saying. And that was like really challenging in the beginning. I started doing that like right from when I started at the firm, and I'm still doing it now. And in the beginning, definitely was a lot of things I wish I knew about project management that I did not know. But yeah.
So a computational designer does a whole bunch of things, really.
I think like architects in general do like a whole bunch of things.
Yeah.
But yeah.
Yeah. You're in that role who can create software, but also manage projects and communicate, be there for extra software and computational guidance.
To like go on the technologies that you could have used or you use during your work. You mentioned AI. Maybe what would you think? How much has AI become a topic in terms of working in big firms, or is there a push for an integration of AI in the design process in general?
Yeah, like in the design process, like the most, I guess, useful aspect of it would be to use it in like rendering or conceptual design. There are software like platforms online that kind of do that. Krea AI is one of them. Krea with a K, Krea, Krea.ai. It's pretty cool because you can essentially like stream your Rhino window into the platform, and it will essentially like you give it a prompt and it would in real time generate like renders or like visualizations based on what geometry or what shapes it sees on your Grasshopper screen or your Rhino screen. And it does do like realistic renders. So that's a really big thing. At my firm, we do have like an internal render tool that kind of learns from all the renders we've done. And then when we have a new like massing model, we can kind of apply that and get like a quick visualization of what that would look like. There have been other attempts, or like there are currently attempts to use AI in more than just rendering, but also like generating like design drawings. But of course, that's like way more complicated, especially when we consider like drawings are very complex and AI makes a lot of mistakes. So we're like not applying that right now, but we're experimenting with that. Another field where AI has been used or has been trying to be used is in trying to kind of manage the amount of RFIs that architecture firms get. So an RFI it stands for request for information. When you like send a project when you're done with the project and the contractor's like building it, they can come back with a lot of questions about like, where does the store go, or what is the color of the store, and etc. And sometimes the RFIs are valid, like the drawings don't actually show that. Other times the RFIs are very simple, like they're in the drawings, but the people, like the contractors, may not know where to look. So it's just like a question and answer, basically Q&A that the contractors come to the architects to do. And in a day, like answer in large projects, like hundreds of them. And it does take up a lot of time to like have to go back to the drawings and find out where you applied like this and have that right answer. So the goal was to like try to use AI to understand like your drawings, first of all, take in your spec sheets, and then not automate like the answer process, like the whole answer, but make it easier for the architect to kind of figure out the answer, especially if it's someone who's like a junior person or who's someone who didn't have like direct access to the project. They can use AI to kind of gather like a large amount of data, process it, and then like have an answer for the contractor that's like relevant in a short amount of time. So that was another interesting project. And yeah, I think like that's pretty much it. Obviously, AI is still like being developed at like a rapid rate. Rendering has been like really the main use case for it, but there are, like I mentioned, these other interesting uses that potentially could be used, but right now it's just like really unreliable. A lot of false positives, as you can already know.
Do you think using AI tools for rendering is like losing a bit of like your authorship in the design, or?
Yeah, there's certainly like a huge, discussion there about like authorship, and also, and we actually had there is a bit of a concern of like using like AI to do a rendering that you didn't train yourself, because that can pull from other sources that are maybe like another firm's designs, and then your render might end up looking like some specific kind of render. And I think there's been like, I'm not sure about like the architectural field, but there's definitely been like copyright cases and a lot of problems with the use of AI. For us internally, we don't push any of the renders out to like the public. It's just mainly just for us to visualize. So I think like being clear with like how you use AI is important, especially like if you understand like what the benefits are and what the disadvantages are. Then you would know like you don't want to use that for like something production level at the moment. But and when it comes to authorship, like as long as I mean there are levels to it. I think it's like a difficult question to answer, but the more you understand AI and like its disadvantages, and the more you like sort of work around that, the more you hold on to your authorship.
Yeah, I think what's interesting to me too is that you guys train the AI off of your own databases of renders, which is something I guess I've never really considered before, but it does bring back a sense of authorship, and it's really interesting that small firm, or I guess big firm, but smaller companies can do this.
So that's the thing, actually. It is more like privileged to like larger companies that have lots of renders already. Like they can have a bank of like renders that they can train with. Smaller companies that are just starting out, like smaller firms, may not have like the renders to train their AI with. So they might have to rely on like a public database, which in the beginning might also like affect how they design. It might like certain AIs have like different distinct style. And I think it's important to like understand that and like work around that. So your creative vision isn't like focused by the AI. It's like rather you're the author, you're in control, not the AI. I think that's important to kind of try to make sure.
Definitely. So at WZMH online, it also says that you've been working on this project, Dotton.
Dot
yeah, is that how you say
it? Yeah.
Don?
So the project is it started with like an idea that Zen and my supervisor and one of the principals at WZMH had about rebuilding sort of like war-torn, like partially destroyed apartment buildings in Ukraine. The idea is to use like these standardized shipping container-sized blocks to kind of infill certain parts of the building that were destroyed, and that you could kind of plop that in like a structural bay, and then sort of stack that and reuse a building that's like partially destroyed but not fully. And then what happened was like we wanted to kind of look into how to automate that, like make it more robotic, and we had to find a way to essentially track the corners as the blocks were kind of coming down, so you would line things up correctly. And the way we tried to do this in the beginning was to use these red dots at the corners. That's kind of where the name came from, like dot on. Nowadays, we're actually experimenting with like Aruco markers, which are like these QR codes that have like a bit more like detail on them, except for just like a little dot. Because a little dot, you can kind of position it easily, but you don't know its like orientation. But with an Aruco marker, it's essentially like a plane in space. And what we're trying to do is like detect like distances, measurements, just with a camera. So that's what dot on is. It's meant to be like a construction tool, maybe even for crane operators to kind of measure things as they're moving, or like robotic applications as well.
Interesting. So that's like software that you helped design, or you designed. And
yeah, we hired a firm to design it for us, but in the beginning, like the early stages, it was just OpenCV. And if you know, like I knew a little bit of it, so we were able to kind of whip out like a version of it, but it was handed off to like someone who actually knew how to do the programming.
Wow. Okay. Well, that's another cool project.
Yeah. So just to like circle back to your, I believe your undergraduate days, I had a chance to visit the Thomas Demand House of Cards exhibition at MoCA, and I know you're part of the contributors to the landscape model that's exhibited there. And Thomas Demand's work is like pretty temporal in the way he does destroy the works after he takes a photo of it. You understand how about you came to this opportunity of working on this model, because it's quite large in scale.
Yeah, it was actually one of the first kind of projects that I had participated in that was like outside of like typically like a school project or something like that, like something to do with a course. It was a really great opportunity to work with such a great team. First of all, it was me and two other students and like two people from the faculty, and like we did quite a bit of testing. Like we started with, it was a very much like an artistic project. Did some digital fabrication involved with the foam and like with the structure. It was all CNC'd foam essentially. They were like these massive 4 foot by like, I think they were 4 foot by 8 foot blocks of foam, and we had to CNC mill them downstairs. There was a lot of foam. The frame itself was designed by Rahul actually, and it was also CNC'd out of plywood. And it was a really fun time. Like I had a lot of interesting moments with working with the material. It was like a little bit about the material is that it was like this paper mache, but it was this very special paper mache that you could only get at like this one specific store, but then they all ran out. So we had to get another paper mache product from another store, but it wasn't all quite the same. But we had to like kind of negotiate with the material to kind of make it work the same way by like mixing different ratios of water and then texturing it. Yeah. What can I say about that project? Did you want to know like anything specific?
Yeah, maybe like I know you're very like a hands-on person, and like you're also like you emphasize a lot about model making. So I would like to know how this project has informed you in terms of your model making skills, and like maybe how you use model making in your design process too.
Yeah. So I used to make a lot of models like by hand without ever going into like the computer before. I think that's kind of what you were taught in the beginning, like in first year, second year to do. But eventually, like I discovered digital fabrication. Like after working at the fabrication lab, I had access to these like the laser cutter, the CNC, mostly the laser cutter and the CNC. Those two machines can let you do so much. And you really get to, because they're so precise, you can really model out your whole like model like in advance in the computer. It does take a lot of time up front, but when you go to fabricate it, it will be very quick to, first of all, make, because it's just the machine working with the material, not you. And then when you go to assemble it, it's also very quick. So a lot of people sort of spend a lot of time building out the model by hand. But what I do is I put more of the emphasis up front in the design to make sure it will work. And then sometimes it doesn't go to plan with the materials, especially. Materials are not perfect. So, but for me, it's been always that like at the end of it, I can assemble the model very quickly if I spend the time up front. And that's something I learned with like working with foam and wood and the CNC for this Thomas de Mer project.
Yeah, I mean, that's interesting because that's kind of the approach I'm trying to learn in my courses in second year. So it's good to know that it works and that this is the direction that people can take as well to build their models more efficiently. We've covered your architecture studies. We've also covered your work as a computational designer. So with all this experience, how much would you say that designers or people in architecture studies should investigate computational design? How much, how useful is it to go into tech stream, especially in this world where all these new software and AI are coming out quickly?
When it comes to design, like rendering and like, you could do AI renders, but they all have like a specific look. And I think it's still important to learn how to render properly and use software properly so you can visualize things accurately. And that's something you learn in like a lot more in design stream. But for me and U of T specifically, Daniels, I think the tech stream has some very like talented individuals like in the faculty. And you also have to like the cohort like in tech versus like design is like much smaller. So you do get more interaction with the profs. And I think that is more valuable to kind of look into. So with AI, I don't know how long we're going to have AI until like it ends the world, but it's no lapse. Come on. It's definitely something. Look, design is always important. Like as an architect, you should know how to design, and like in design stream, you get a lot of portfolio worthy projects. That's something I noticed. Traditional like firms like to see more like drawings of like floor plans and like stuff like that. So if you care for that, like go that route. But tech is where I learned like the most. And if you have like the passion for it, I'd say go for it, because you do get these like niche positions that are they're very well paid and they're very like in demand, but you have to kind of be passionate about it.
Yeah, I mean, that's kind of the direction I'm going in. So especially for the pay part, that's really good to hear.
So a lot of people are thinking about grad school or like a specialized MArch tracks. From your experience, what do you think students should be deciding on to be going deeper into the tech focused paths?
And so in terms of the master's program, like if you're deciding on doing a master's, make sure that like, first of all, you might not need to get a master's degree to do an architectural, especially at U of T. If you just want to do architectural design, I would suggest like work for a year after undergrad and like figure out like what specific part of architecture you want to do. And then you could, shop around for master's programs in Canada or like in the US, in Europe even. Like there's specific programs like for computation or for design, obviously, but sometimes you might not even want to do architecture, and like going straight into our master's from undergrad, something like, unfortunately, with the U of T Daniels program, we have to do because it's not accredited. But I think it's best to like take a year and like work and then come back for master's. U of T's like actually got a really good master's program.
Thank you. I'll keep that in mind when I apply.
Yeah. Okay, well, Sadi, thank you so much for taking the time to come with us today.
Happy to be here. Yeah, no, this is fun.
That's all for this episode of The Next Generation of Computational Designers with Sadi Wali from the Future Living Lab podcast. We were your hosts, Matt
and Kyla. Thank you to our team, Janice, Kushi, Nathania, Alejandra, and our other co-host, Amberine. You can find us on Instagram, the Future Living Lab, YouTube, and Spotify.